Morning, everybody. This morning we're going to talk about parallel lines cut by a transversal and the angles that we find there. That's the first thing we're going to talk about. So let's zero in on two lines intersecting. Okay, when two lines intersect, you could. I measured this angle with my handy dandy protractor. 62 and 62 plus 118 equals 180. So we're going to use straight angle pairs a lot today. And across from this angle, you could do it again. Just looking at this line, now that you calculated this 118 here, if you even just start with one, I've got one angle. Okay, I measured that at 62. I have a straight line here, so I know 62 plus this angle has to equal 180, so I can calculate that. 118. Then if I turn, and I even just forget about that 62 right there, 118 plus what gives me 180, right, again, because I'm on a straight line again. Okay, has to be 62. Well, you look at this, these vertical angles are congruent. Okay, 62 and 62, 118, 118. All right, and now I'm going to talk about what happens, the special relationships when you have parallel lines. Okay, and we're not going to spend a bunch of time memorizing all these interesting names like alternate interior angles and same side exterior and same side interior and all this stuff. We'll just look at the relationships, and it would help if you had tracing paper like I've got here, but you don't have to. First, just a quick math joke. There's two parallel lines. They have so much in common. It's just a shame that they'll never meet. I had to throw that one in there. Okay, so we got our. Wait, I have some tracing paper, and I went ahead and traced this little intersection here. 62, 118, 62, 118. If I move it up along I put T on here for transversal. I move it up along the transversal to the other line that's parallel. Has to be parallel lines. And there's how all the angles line up. In a parallel lines, with parallel lines along this transversal, this angle here on the same side of the transversal up here on the inside, that also adds up to 180. It's another supplementary angle. This same side of the transversal inside the parallel lines. If I come here, boom, and I turn again, I've turned 180 degrees. Okay, and then you can calculate all the rest of these lines up, and you can see how it lines up just right there, same as it was down at the other intersection. So nothing too spectacular there with these special relationships. So you can see all that, use that to solve the first two problems. Okay, on your My Math Lab assignment for today. Just look at them. It can be turned any way, right? You can turn these lines this way, turn them this way. Doesn't matter. Just pay attention to which lines are parallel and which line is the transversal. Figure out all your angles using vertical angles are congruent and straight angle pairs. And move up all these angles to fit right here. Sorry about the crying in the background.